Welcome back. This is an Aleks training video on calculating average molecular speed. So, some very smart people have figured out just how fast a molecule is bumping around in a gas tank, like a oxygen tank. So, they're going to give you a gas. This is xenon gas. They're going to give you a temperature and a pressure and ask you to find out at that temperature and pressure how fast is that molecule bopping around. Okay, pretty cool. It's pretty hard, but I think it's pretty cool. So let me show you stuff. I've written down some stuff so that you can, so I don't have to write it in front of you. You can do this in your notes. On the top, I've given you two formula. The kinetic theory of gases is the one from this chapter. This is the new one. So E sub k means kinetic energy. The kinetic energy, or the energy due to motion of a molecule, okay, or an atom, at a certain temperature is equal to 3/2 times Boseman's constant. And Boseman was a Russian scientist who figured out just how, the proportions of speed at different temperatures, how fast something is moving at different temperatures. So there's a constant that makes all this work. He did all the hard work. So Boseman's constant's here. I've given it to you here, and we'll use it in a second. Times the temperature, and the temperature is going to be in Kelvin. Anytime that you use temperature in the gas laws, you're going to use it in Kelvin. Kelvin is 273.15 degrees hotter or higher than Celsius. So whatever the Celsius temperature is, add 273.15 and you'll have it. So I derived in red here the formula. So I multiplied by 2. So I have 2 on the right side. Now I divided by m. Now I have v squared equals. Then I took the square root. So here is the formula we're going to derive, or that we're going to start filling in. So v equals square root of 3 Boseman's constant times temperature Kelvin over mass. Now, velocity, we understand velocity as speed as how much of a distance are you coming in a certain amount of time, so meters per second. If we do all this, you're going to see that Boseman is in joules over meters here. That means how much energy is it taking to make you go a certain distance, and that's really not to our understanding. We don't understand that. We want how far is it going in a certain amount of time. So we're going to change the joule here to its equivalent, 1 kilogram meter squared over seconds squared, so that you'll end up with meters and seconds, and then we're going to divide by the mass. And the mass, we want 1 atom of xenon. Okay, so this is simply from the periodic table, 131.23293 divided by Avogadro's number 6.2214 times 10 to the 23rd. So that'll, when you reduce that, it'll be 1 atom of xenon. All right, so let's put this together. And see what we can do. Remember, we're in square root here. So at least I like the 3. The 3 makes sense. All right. So I've got the square root of 3. Now Boseman's constant. Boseman's constant, I want to put it in its equivalent. So instead of joules, I'm going to use this in place of the joule because I want meters per second. So it's going to be the same number. It'll be 1.38065 times 10 to the negative 23 kilograms meter squared second squared per Kelvin. Okay, that is Boseman's constant. Now we want the temperature that we were given. So we were given -39. So let's do that up here. -39 Celsius plus 273.15 equals 234.15 Kelvin. And that goes here. 234.15 Kelvin. Kelvin now cancels because I've got Kelvin, -1 Kelvin. All right, so that's on the top. On the bottom, I need the mass of xenon. Okay, so let's look over here just a minute. I've got the grams per mole, 131.293 over 6.022 times 10 to the 23rd. This is going to give you grams. Okay, you can see I've got grams here. I need kilograms to cancel with kilograms. So I need to change this into kilograms. So I'm going to say 1,000 grams in 1 kilogram. Okay, and so let's do the math here. The math is going to be 2.18017 times 10 to the negative 25 kilograms. So grams will cancel. We're now in kilograms. When I put that on the bottom, then it'll cancel with kilograms in the other. All right. So that's what I'm going to put on the bottom. I'm going to put 2.18017 times 10 to the negative 25 kilograms. Kilograms will cancel. All right, this is going to be V equals, okay? When I take the square root, I'm going to have mass times, or meters times meters. It'll go down to meters. Seconds to the minus 2, that's a minus. Seconds to the minus 2 will go down to seconds to the minus 1. All right, so it's meters per second. So when I square root that, the meters and seconds aren't doubled anymore. So I'm going to do this calculation. 3 times 1.38065 times 10 to the negative 23, okay, times 234.15 equals, divided by 2.18017 times 10 to the negative 25 equals, I have V equals 210.9135. Okay, you know that never trust the calculator. This is now in meters per second. Always go to three significant figures. If in doubt, always go 3 significant figures. So this is going to be 2. Velocity will be 211 meters per second. So yeah, it's hard. Yeah, we'll do it as many times as you need to. Just see me in class.